All right, today we're going to work on version control, specifically working on Git and GitHub and learning these tools and how to use them and why we want to use them. So this is specifically prepared for my students, but I think it's generic enough. It pretty much applies to anyone. So the audience for this video is anyone who really doesn't understand version control, hasn't worked with it yet, very basic. Very introductory, so we're going to assume that you don't have any prior knowledge of version control, and we're going to go from there. But we do have some assumptions, and that is the first one is we assume that you know how to use the command prompt reasonably well. So that's this thing right here. So you should be able to come to the command prompt, and you should be able to type commands, and you should be able to understand the results of those commands. So that's one assumption. We also assume that you understand basic things like what a file is and how to edit the file. For example, you know how to open up a text editor, which I'm showing right here, and you know how to edit that file. You understand directories and folders and that sort of thing. So basic computer knowledge is assumed, but we assume that you don't understand version control or anything that has to do with it, and that's what we're going to talk about. So let's get a few terms out of the way and a few ideas to ground us, okay? So I'm going to use two terms. One is going to be Git, okay, and one is going to be GitHub. Those are two separate things that I don't want to say have nothing to do with each other. Of course, they have a lot to do with each other, but they're two completely different concepts, okay? Git is going to be your utility. Git is going to be something that you use at the command prompt or through an IDE or some other tool that's going to allow you to do version control. So for example, if I come out here and I type git version, okay, it can tell me what the version of that is. So I can see what's going on by giving the git command and asking it, different things or telling it to do things for me. So Git is a utility, it's a tool, it's something that you install. GitHub, okay, is an online repository. So I'm gonna go here to my GitHub account. So GitHub is an online service that allows you to store code, version code, manage code online. And it uses Git. Okay, so Git is kind of like the glue between the two, right? Git is your utility on your machine, right? And Git is the utility behind GitHub. But GitHub is this big, massive service that allows you to manage all of your stuff online. Okay, so two totally different things, and we have to make sure that we understand the difference between them. One is a utility that you will use to do version control. The other one is a large online service that you use to manage your code repositories, share code, work with others. It's a collaborative tool, it's a storage tool, it's a lot of things. Okay, we're gonna cover some of that stuff as we go. All right, so Git does not equal GitHub. Make sure we understand that, right? And we're going to cover our Git concepts, Git workflows, GitHub workflows, some of the command line things that you need to do. We're going to cover this process a lot, right? This is the process that you will use as you go to version your software properly and keep track of it, okay? So what's the purpose of all of this? The purpose is just what we said, right? It's versioning. It's controlling your software. It's tracking changes. So when you work on software, you have to know what you did and where you're going. You have to know what other people did. So you got to imagine, right? Most of the time you're working in a team, you're working with other people, and you have to collaborate somehow. So these tools are what allow you to collaborate. It's what allows you to keep track of your software, what allows you to do feature enhancements, or if you screw something up, what allows you to go backwards to a known good state and then fix it up and go from there. So it does a lot of things, right? And the one thing I always like to tell people, especially if you're a beginning programming student, you've just started out in this field, or you think you want to get into this field, this is essential. This is not knowing this is a non-starter. You cannot do anything without this. It's not possible. Okay. So, I mean, everybody uses some form of version control. Git and GitHub are the most popular. They've pretty much ruled the world at this point. I think it's something crazy like 80–90% of all code is managed this way. But even if you work for a company or work on your own and you don't specifically use these and you use some other tools, because there are other ones out there, it doesn't matter. The concepts are all the same. So you gotta start somewhere, and we're gonna start with the biggest and most popular. And as I said, like you can learn all the programming you want, but if you don't also know this, you can't be employed. You can't do anything. You can't even manage your own projects, let alone professional projects. So you really need this tool and you need to understand it. Okay, so where this tutorial fits, this is a little class specific. So if you're not in one of my courses, but you're watching this, this kind of doesn't really apply to you, but you can get the idea of where we're going, right? So in my classes, one of the first things we do is we set up our environment, okay? And that's where we install things. We install the Git utility. We install virtual machines if we need to. We understand the command line. We do things like that. So this is sort of setting up, okay? Now, then a second assignment, whether they're called 1A or 1B or 1 or 2 or whatever it happens to be, doesn't matter. It's just your second assignment or your second part of your first assignment will be this, what we're doing right now. So this is where this fits. It fits right here. So this tutorial assumes your environment is set up. Okay, so what does that mean? That means the stuff that we already talked about, and you have the Git utility installed, and you can do this. Okay, if you can come to the command prompt and you can type Git version, and you basically understand command prompt usage, you're good to go. You're ready for this tutorial. So that's what this first thing is, and we're here in the second thing. Okay, so that's where we are. And then if you're in one of my courses, we continue on, right? Then the next assignment is a simple programming assignment to get you used to course requirements. And then by assignment 3, we're up and running and doing everything the way we should be doing professionally. All right, so I covered a little bit of this already, but let's go over it again. Git repositories and GitHub are not the same thing. These are all different concepts you'll understand. Git, a distributed version control system. It records history of a project as commits. Okay, a commit is sort of when you lock in a change and you put a note on it that says like what change you locked in. So Git is the distributed version control system. Notice the capital G here. That's the name of the system. This lowercase g, this thing, when I type that, okay, when I type that and I ask it something or tell it to do something, that's the utility that lets you manage that distributed version control system. So like I just did a git status, but it says fatal because I'm not in a repository. I haven't done anything yet. But I can always ask it what its version is, right? That's always a valid question. All right. So know the difference between the idea that big capital G here means we're talking about the distributed version control system. Lowercase g is the utility that allows you to implement and work with that system, okay? A Git repository is a versioned project history managed by Git. Okay, so when we say repository, we're talking about the collection of things that go together to make a project. Okay, and the history behind it. That's the important part. It's the history. Okay, so when we work on software, we don't just code wherever we want and just you know, kind of just go from one file to the next and just make changes and do whatever. Okay, we work very methodically. We make a change, we test the change. Once we see the change is good and we feel like it belongs as part of the code base, we stop, we commit it. We call that committing. We say like this is you know, presumably my final good tested version. It's never your final good tested version, but that's what we say it is. And then we lock it in. Okay, when we lock it in, we put a note on it that says this is what I did, this is why I did it, this is why this was necessary. Okay, we put that note on it, then we move on and we test and we code some more. So that each step along the way, we have a record of what we did and how we did it. Right, and it's far more complicated than that, but that's the basic idea. Okay. So that's what a repository is. Now, a repository can live on your computer. It can live someplace else. It can live on both. Okay, and that's where GitHub comes in. GitHub is the someplace else. Okay, so let me change this a little bit here. Okay, so GitHub is the service that hosts Git repositories. All right, so what we're going to see in this tutorial is when we start working with Git, you're going to create a repository on your computer. All right. And then later on, we're going to connect it to GitHub, and then we're going to put that repository on GitHub. Now it lives in 2 different places. So a repository can live on your computer, only on your computer. It can live on your computer and on GitHub. Or if you've never worked with it or never touched it, it could live only on GitHub because you may like see it and observe it. You may look at it, but maybe it just exists there. Maybe you didn't write it or it's somebody else's and you're looking at it. So it can exist in any one of those 3 states, only on your computer, only on GitHub from your perspective, or both, okay, where they're synchronized and they work together, okay, or they stay synchronized together ideally. Okay, so Git can work with no GitHub account, but if you want to use GitHub, you need an account and that's where you host repositories. So this thing out here, this is just the utility. Like you just download the utility and start using it. And I think you'll find, like once you get to understand this and you see how it works, even if you're never going to put your code online, even if you're only working by yourself, you're still going to use this. Okay, so I do a lot of projects that are never going to see the light of day beyond my computer. I do a lot of coding for just myself, for writing my own utilities, or I just want to do something for myself, or I want to experiment with something. I still do version control as I go. Like I never just code. Okay, just free form code and just what happens happens. Okay, so even when I'm working by myself, I will use Git. It doesn't need an account. It doesn't need any security. It doesn't need anything. It's just one of the developer tools that you need to learn how to use to manage your code, even if it's just for yourself. But most of the time, it's not for yourself, right? You don't code for yourself most of the time. You code for other people, all right? And that's where GitHub is going to come in. That's the collaboration point. All right. So the four places you have to keep separate in your mind. You have to think of these things as different places, and it's very conceptual. Okay. Um, uh, Working directory. Okay, what's working directory? Working directory is where you're going to work. So, for example, like I got a file explorer window open here, right? This is my home directory. I might make a directory here called code. Inside that directory called code, I might put like, project and a project directory. Inside that project directory, I'm keeping code. Right? I'm keeping a particular project. So that's your working directory on your computer. So this is a file explorer window, and I'm just showing my folders on my computer. So that's your working directory, local to you. We say local, we mean your computer. Staging area. All right, this one's very conceptual. The staging area is where we put files when they're ready to be committed. Not actually committed yet. I mean, they're going to be committed, not committed yet. Okay, and this is a conceptual thing. Like I can't. There's no place on my machine I can point to and go, oh look, here's the staging area. Okay, staging area is a concept. It's when you mark something to be ready to be committed, but it's not committed yet. So it's selected changes prepared for the next commit, right? It's like I said, it's not a real physical area. I mean, it is if you dig down deep enough and you go looking for it, you will find evidence of it on your hard drive. But that's not the point. The point is it's conceptual for all practical purposes. It's things that you marked to be staged to be committed the next time you commit. Okay. Local history. Again, it's a concept. Okay, it does physically exist. There's a file or a collection of files that actually have your local history, but from your perspective, it's a concept. It's a history of all of the changes you've made in a particular project. Okay. Now, remote repository. So that's back to a real physical thing, right? That's a copy of your repository hosted someplace else. There's lots of other places you could put it. For example, Bitbucket is a competing service to GitHub. We're going to use GitHub. All right. So a remote repository is one of these things out here. Okay. So like this is my account on GitHub. And then, for example, like these are repositories. I can click on one. We can go in and there's code in here. Okay. And I can like dig in and I can look at the code and I can pull it up. Okay, and I can look at the individual files. So this is one project, and here are all the files listed. And you can see there's a history associated with these things, right? So I can look and see at my commits. This is my history of coding this stuff, okay? So you can see all these are my commit messages as I go. All right, let's get out of here. Let's go back to the presentation. All right, so these are the places you need to keep separate in your mind. Not always physical, sometimes conceptual, but it's important to understand them. All right, so the normal way you work. Okay, the normal way you work is you're going to edit a code file. You're going to test it to make sure it works well. If it doesn't, you're going to go back to editing and fix it. So there's kind of a loop right here. All right. So you're going to inspect everything to make sure everything is proper. After you've coded something, you're sure it's tested well. You're sure it's good. You inspect everything. You inspect what is my Git status? Like, are my files in order? Did I forget anything? Did I, the administrative kind of stuff. That's what we mean by inspect everything, right? Then you're going to stage. Okay, staging says I'm marking this thing to be ready for the commit. And the reason we have a separate stage process is because sometimes you're working on multiple things. Like imagine you're working in 3 files and you're making changes in all 3. But one file has something complete and you want to commit it before the other 2, okay, or maybe before the 3rd one, right? So that one you know is done. So you go, okay, I'm marking this to be committed next time I commit. And more often than not, you do it right on the spot. The next thing is a commit, right? But it doesn't have to be. You could mark it for committing. Maybe you go work in one of the other 3 files and you fix something in there that connects to the 3rd file. Then you mark it for stage for commit. all right? Then maybe you work in the first file, make some changes there. So now all three files have changes, but only two of them are staged for commit because you know those are tested and good to go on their own. So at some point, what you do is you go, okay, now I want to commit. And if you do it at that exact moment where two are staged and one is not, even though that they all have changes, only the two that were staged go out for commit. Okay, so the staging process is a way that you can separate out um, uh, changes and files to say like, okay, I know lots of things has changed, but these are ready to go. Like put them in the pipeline to go next on the commit. Okay. Then at some point you're ready for the commit. Now in real life, what really happens is typically you go through the edits, test, and inspect on one or two files, and you immediately stage them, immediately commit them. Okay, like usually it's quick. Not always. Like sometimes there's intermediate steps, but typically like you do these kind of close together. All right. And then the last thing is if you have a remote repository, like this last step is if you have a remote repository, you then push the code to the remote repository, like push it up to GitHub. So these first steps, you can always do those. Okay, whether you're local only or local and remote, it doesn't matter. You're always going to do those. But if you're also remote, meaning if you also are working with a repository on GitHub, at some point you've got to send the code up there because it's only on your machine. Up until this point, it's only on your computer. But then you push it, and that sends it to the remote repository, right? So keep those terms in mind. We say local repository, we mean the files on your computer and the history on your computer. That's the important part, the history on your computer. That's not going to be the same as the history in the remote because you're going to be working local, and your local will get ahead of the remote, okay? And then at some point, you have to catch them up. All right, so those histories will diverge and come back together and diverge and come back together. And then in a collaborative environment, like when you're working with other people on the same code, then you've got lots of coordination, right? Like you're working on something in your local, they're working on something in their local, and between the two of you, there's a remote. So you've moved your code forward beyond the remote history, and they've moved their code forward beyond the remote history, right? So now both of you are ahead of the remote, and then you commit to the remote, all right, and now you and the remote are together, but the other person, if they haven't pushed yet, that they're still behind, right? And then maybe that person picks up your changes because maybe they were important to them. They pick up your changes, they catch up to you, but the remote's still behind them, right? And then maybe at some point they push, and then everybody's coordinated again. So there's lots of combinations here and lots of complexity. Okay, in the collaborative case, when you're working with other people, there's a lot of moving parts, right? So let's go a little more formal definition. A commit is a coherent checkpoint, not a random save. So don't think of it as a save. That's not the way to think of commits. When you save a document, like you're working on something, you save it, you're doing it so you don't lose it. You're doing it so that you lock in your changes and move forward. But that's not random either. You're choosing when to do it, but it could be random and it could be on a schedule. It could be like every 5 minutes. Like, so you have autosave turned on and you're working on documents or emails and they just save every 5 minutes. That is not what commits are. Commits are specifically logical, fixed, tested, inspected changes that you are certifying this is good to go. Okay. When you make a commit, you're saying this portion I'm committing is done. Okay. Or at least it's done logically at this point. It doesn't mean like the feature is completed. We work much smaller than that. It doesn't mean the application's completed. We work much smaller than that. It means some logical step that's self-contained, that I can explain, that I can test, that I can be sure is correct, is ready to go. Okay, that's what a commit is, right? And we when they're that small, we talk about them as they're called atomic commits. All right, atomic commit means it's a single, self-contained, very logical change. All right. So now we don't always do atomic commits. Like atomic commits is like the most fine-grained. If you're doing an atomic commit, you're committing a lot. You're committing with each little well-tested change, and that could be only a few lines of code. So in my courses, okay, if you're taking one of my courses, you're going to have to do atomic commits, okay, because we're training you, right? We're training you as to the process. But in real life, as a professional, you're not really making atomic commits most of the time. Most of the time, you're making groups of atomic commits, right? So like for me personally, like when I do professional work, which I still do, like I still consult, I still do professional work. I still work, weekly on professional code that goes into other companies' code bases. So when I work then, do I actually like commit every like 3-4 lines of code? Like, no. I typically commit with a reasonably good sized feature. Okay, not a huge feature, but if let's say like the example could be I'm taking in a file, I'm doing some processing, and I'm like sending things out to a database. That's a single self-contained small feature. Okay, you can think of it as small or like relatively good size, right? That I can justify with one commit. But anything much bigger than that is too big. So you really want to get a feel for how big should a commit be. The smallest commit, we call it an atomic commit. It means a single, well-defined thing it's not a feature. It's not something that works, on a grand scale. It's not even going to be like, like it's not going to be a whole file. Certainly not, probably. It might be if it's at the beginning of a file, but it's going to be small, very small, a few lines of code versus a little bit higher level, you're talking about a small part of a feature. Okay, then a little higher level is like a feature. But even that, you got to keep it kind of small because it's a big feature. You got to break it down. That's as big as we go. Okay, definitely as big as we go. The way I think of it as, if you're a beginner, if you've gone more than I'd say 2 to 10 lines of code without a commit, you're going too far. Okay, that's about it because you're doing small things. You're a beginner, small things, like those are meaningful small things. If you're a professional, you're very advanced, you're working on big things. Yeah, you might get it like 100 lines in, maybe. Okay, like that's reasonable. Much more than that, no. You've gone way too far before a commit. If I'm like at 400 lines of code and I have not done a commit, I've screwed up. Okay, so that's not acceptable. Okay, all right. So you should also be able to explain what each commit accomplished. All right, that you have to have an explanation. As part of your commit process, you make a message. Okay. We also want to push regularly. So pushing, this is a different thing. Pushing is when you send it up to the repository. So first of all, we have to assume we have a repository. We're not just working locally. And when do you push? Well, it depends, right? Like technically, you only have to push once at the end. Okay, so if you really only need to push once at the end when you want somebody else to get your work, right? That's the only time you have to push because until then you've got it all local and you'll send it up later when it matters. Okay, but in real life you push more often, and there's reasons for that. One reason is because you want to save your work someplace else to keep it safe. It doesn't happen often, but it happens. Like where, you're working on something big, your computer crashes, hard drive crashes, something goes wrong, you screw something up, you delete files and you can't get them back, something happens. If you've pushed regularly, then you have a copy someplace else. So pushing keeps that copy up to date. All right. So one reason is safety. You want to push regularly for safety. Another reason could be there might be some process as part of the push that checks your work. Okay, so for example, other developers can check your work or automated process can check your work, things like that. So for me, for my students in my courses, when you push, there's going to be an automated series of tests that run. So you want to push often because what it's going to do is it's going to put your code through a series of tests and then alert you to what is and what isn't working. So it's an extra way to help you develop. Okay, there's automated tests going on when you push. Now, technically, professionally, push once at the end is I don't recommend that, but you can get away with it, right? But in all other circumstances, you want to push regularly. Okay, you don't have to push every commit, but like get on a schedule. Like for me personally, professionally, I tend to push once a day. So at the end of the day, when I'm done working, I push it all, walk away. Okay, um, maybe a little more often is probably smarter. All right, so let's start with a local project. Let's see how this goes. Okay, so now if you are in my courses, you're going to want to do this because I'm going to ask for proof. So if you're just watching this to learn how to do version control, understand what it is, just follow along. I would suggest doing this as you go. If you're in my courses, then you need to actually do this. So you're going to have to like stop the video and actually do this procedure because I'm going to ask you to turn this in at some point. All right. So we want to start with let's make a local project. Okay. Let me back up too. I should back up and mention a point. So there's two ways you can start a project. Okay. One way you can start a project is you start locally, that's on your machine. You work on stuff and you send it to GitHub eventually. Okay. And it becomes a remote repository. So that's one way. The other way you can work is there's already a remote repository that you don't have and you pull it down. So we say push when we send it up, and we say pull when we get a repository, okay, or clone. When you hear pull or clone, very similar concepts. Not exactly the same, but very similar, okay? So push means send it up, and pull or clone means pull it down, okay? So you can work in either direction when you start a project. So for example, if I'm coming onto a job and other people have already done work before me, I want to jump into that project, right? So the very first thing I do is I don't start my local project. What I do is I open up an area on my computer. I do create a directory, but then I pull or I clone the other people's work that they've already done, and then I have a copy of it, and then I can start working with them. Okay, so that's one example. The other example is you're not working with somebody else's stuff. You're starting from scratch, and you start locally, and then you push it up. All right. So two ways to go. You can start local and push it up, or you can start remote and pull it down. But after you get started, after that point, everything else is the same. Okay, that's just how you like the choice is how you start. Like that, like do you start local or do you start remote? But once you get past that point, the starting point, everything else after that is exactly the same. Okay, because once you're synced, and there you go. All right. So we start with a local project. We're going to work in the command prompt. All right. So we're going to work here. So I'm just on my home directory, no place else. I'm just going to use my home directory to start. You should pick someplace smart for your code, wherever you want to go. Like you want to make an area. Like don't do things like work on your desktop or work in your downloads folder. That's not smart. Make a special place just for your work. So what I'm going to do is I'm just going to make something simple. I'm going to make a directory called code. And then inside that directory, I want to put put another directory called Git demo. Okay, so I'm going to do make directory and create it, and I'm going to change to that directory. So now I could do it out here. I could do it from here, right? I could right click and I could choose a new folder. I could make code, and then I could go in there and I could choose new folder, and I could make Git demo. Okay, but I don't need to work there. And if you're going to be a developer, you need to work at the command line. That's important, right? So you need to know how to work at the command line. So I'm going to start with that. I'm going to do this. I'm going to say make directory. Okay, so, okay, and this is going to make two directories at once. Okay, so so there is no code directory right now. If I check for a code directory, if I do ll code, there's nothing there. There's no, it doesn't exist. So ll is listing my files, and it doesn't exist yet. So I'm going to make a directory. Okay, and I want it to create more than one directory, right? So that's what the switch is for. I want to create more than one directory. I want to say make a directory in my home directory. That's what this little squiggly line is, my home directory called code. And then inside that, make another directory called git demo. Okay, so I want to say in my home directory, make a directory called code. And then in that, put another directory called git demo. Okay, so it's going to create those two directories. Right now, I can prove it's created by, I could come out here and look at it graphically. I could come out here and I could go, okay, where is it now? It's right. Did we create it? Where is it? Well, it's here somewhere. It's not refreshed. I don't see it. I'm probably staring right at it and just don't see it. Or maybe something went weird with it. Uh, let's see if I can just change to it. Yeah, it was there. Okay, I don't know. I didn't see it out. I didn't see it on the top level. You're probably sitting out there going, there it is. Okay, I didn't see it. So it was there. It was on the top level, and then I can go in there and look at it, right? So there's nothing in here because I just created these. But I don't want to work here. Working outside in the graphical environment is too difficult. So I go change directory, and I want to go into these directories. Okay, so now I'm inside of them. You can tell by the prompt, right? And I can look and see, well, what's here? So you can do ls-alf, which says list all the files, including hidden files. There's nothing there. Also, I have an alias to ll does the same thing. Nothing there. Okay, so there's nothing in that area. All right, so I've done that. That's this example. And now I'm gonna work in that directory. Okay, so you create a project directory somewhere predictable, put files for one project in that directory, and we run git commands from from the root of that project. So that's our working area. That's what we mean by local project area. Okay, so now let's configure Git. All right, so I'm not going to do this because my Git's already configured, and I don't want to set these things or mess with them. Okay, so I'll just explain them, but I'm not going to do them. So since you're probably just getting started with Git, you probably just installed it. You haven't done this stuff yet. Okay, so you want to do if you have done this stuff, don't do it again. Like it's already set. But we want to configure some parameters, right? We want Git to know things about who we are. We want it to understand like how to manage itself and do things, right? So this is the command you want to execute. So literally you can copy this, come out here, and you can do that, and then like change it to your actual name, like put your own name in here, right? Like whatever you want to put. That'll set your name. Okay, I'm not going to do it because my parameters are already set and I don't want to mess them up. Then do the next one, right? Configure your email, right? This is supposed to be one command. It's kind of sloppy on here, but this is one command right here. So you would do that, and then this is another command. Okay, now what that one's going to do is that third command is going to say when I create repositories, I want the main work of code to be actually called main. So this is a name right here. This is We're not going to talk too much about branches right now. We're going to just briefly mention them later. Don't worry about it. This is just saying that when I work on my code, I want the main line of code, like the main production line, to literally be called main. Okay, so I'm just setting that name. And then I can list it. I could say like, well, what are my configurations, right? So like you can do this, and then you can list your configurations, okay, to make sure that you got them right. If you didn't get them right, just re-execute you don't have to delete or anything like that. Just re-execute the command that you screwed up. Like say you didn't get your email right. Well, just do this again and get your email right, okay? So Git records author information in the commits. That's why you want to do this. So use your email associated with your GitHub, and then set your branch properly, check it. You do this once per environment, okay? Once per environment. So if you, and I've often had beginner students, they set up their machine, their home machine or their laptop or whatever, and then every once in a while, like at least once a semester, someone says, "Oh, I'm working in the labs at school," or "I went on vacation, I'm on my friend's computer," and but I want to work on my stuff. I didn't bring my laptop. I don't have my laptop. Like, is there a way to work on my code? Well, of course, because that's what this is for. Like, assuming you've used GitHub, assuming you push your code up to GitHub, you can then go anywhere to anybody's computer and pull your own code down and work on it. But you have to set up that environment because it's a new one. So each environment gets set up once, and then you don't worry about it. If you're always working on the same machine, you won't set it up again, okay? Unless you want to change it. All right. All right, so we want to initialize our local repository. So we haven't done anything yet. We've configured Git a little bit, but we haven't actually created a repository, right? So the way to do that is with the git init command. So we do git init, okay? And it says initialized empty Git repository in that spot, okay? And we can look at it. We can list the files, and we can see, look, there's a new directory there, okay? And it's called Git. We can see it here as well. Okay, so here's my folder that I'm working in. There's Git. So what is that? That's your repository. Don't touch it, okay? I can't stress that enough. Don't touch it. Leave it alone. Don't even look in it. Just leave it alone, okay? It's not for you to play with. It's managed by Git, and it does everything you need it to do, and you never have to look inside. I've been doing this for I don't know how many decades, and I have never looked inside. I don't want to. I don't care. It's none of my business in there, okay? So this contains Git's internal database and configuration for that product. Don't touch it. Okay, just leave it there. Okay. All right. So now we have a repository. We have nothing in it. We have no files, but we have an empty repository. All right. Next thing you want to learn about is you're going to need to do this thing called git ignore. Okay, it's another kind of configuration file, right? It's what tells Git what not to put in a repository. This is really important, and it's a little counterintuitive to beginners because like the very first thing you do with a new repository is you don't start putting things in. The very first thing you do is you tell Git what not to put in, right? That's really important. It's way more important than you think it is, okay? So the first step is I have to tell Git what not to put in, right? Let's get that started. It's just a text file, and yes, there's a leading dot on it. Okay, that marks it as a hidden file. Okay, because it's going to be an administrative configuration file. We don't normally want to see it. So this marks as a hidden file, and the name of it is git ignore. It has to be exactly that way. Not, don't forget the period. That won't work. Don't put .txt at the end. That won't work. Don't put a period at the end. That won't work. It has to be exactly this. All right. So now there's lots of ways we can do this. I could come out here. I could right click. I could choose new text file. I could change the name, and then I could start working with it. I could do that. I could just come out here and I could just start putting things in a git ignore file here, and then come up here and go, save as. Okay, or over here, I guess. Yeah, save as. I can go save as. All right, and I can save it in the proper place. But I like working at the command prompt, so I'm going to do this. I'm going to use the touch command. This works on Linux and Mac. I don't know if it works on Windows or not. I don't think so, but I don't know. Someone try it. Let me know. So I'm going to work out here. I'm going to say git ignore. You don't have to do it here, You can do it any way you want. It doesn't matter. The only point is create a text file called that. How you get there makes no difference. So I'm going to do that. And if we look inside the directory now, there it is. Okay, so I created it, but it's empty. There's nothing there. And now I can say I want to edit that file. I could do it from here. Okay, I could edit the file right in this window if I want to, or I could come out here and I could see that it exists out here, and I can just put it in my text editor, right? I could just put it in my text editor. Now it's here, and then I can start editing it. So I'm going to do that. So I'm going to, so for me, I think I do probably what a lot of developers do. I move back and forth between the graphical interface and the command prompt, however I feel like it. Okay, I do something with the command prompt, probably 60, 70% of like my administrative type stuff, maybe even more, like 80% of my administrative type stuff is at the command prompt. But my editing, I like to do my editing in the graphical environment, right? Because I usually have IDEs and I have tools and I have graphical tools that I want to use, so I mix and match. Not always, like sometimes I work strictly at the command prompt and nothing else, okay, especially if I'm working remote. But you work however you want, like whatever way works as long as you get to the end result. All right, so now what goes in here? So that's the question, right? We can highlight this and just put it in as is, and then I'll explain it. All right. There's lots of ways you can approach a git ignore file. This way is the probably more common way. Okay. Anything that begins with this hashtag, all right, that's a comment. That doesn't mean anything. It's just a comment. I could write anything in there. Okay. So I could just write, I could just come up here and go, no, this is my git ignore file. Okay, that doesn't mean anything. It's totally irrelevant. Okay. Now these next things, they matter. Okay, so we're going to separate out the comments. Okay. So this one is saying, the reason that there's a Python comment here is this one is saying, well, this repository looks like it might, maybe I'm planning on having Python files and C++ files, okay? And I want to make sure I manage them properly. So what this is saying is, if I'm gonna work in Python, ignore something called the PyCache directory, because that's gonna be temporary files that the Python interpreter makes. We don't ever wanna commit those. Ignore these PYC files, ignore my virtual environments. Okay, so you won't know what that means more than likely. If you're watching this video, you probably don't know what those mean, but it's fine, it doesn't matter. What these are Python sort of administrative files. They're not part of your code. They're part of your local environment's setup, and you never want to commit them. Okay, you never want to commit them. Let's go back out here to the description here. Not every file in a project belongs in version control. In fact, a lot of files don't belong in version control, okay? We track source code, documentation, tests, and configurations meant to be shared. That's the key right here. Meant to be shared. If it's not meant to be shared, you do not track it, okay? And there are a lot of things that are not meant to be shared. We don't share build outputs. We don't share caches. That's what this thing is. This is a cache, right? We don't share local IDE settings. We don't share virtual environments. We don't share secrets. We don't share passwords. We don't share OS garbage. Okay. So what we do is we create this file that says, don't ever allow these things in. Like never let these files get into my repository. Okay. So in the C++ case, these are intermediate object files. These are executable files. These are probably IDE files or some other like PyCache type files. So if you're working on a Mac, it creates these things called DS store files. Like Mac people, you can always tell a Mac person because you look in their repository and they always let things escape. Okay, so like the Mac people are notorious for having version control, for having repositories where these files are in their repository. Okay, because they weren't paying attention and they got them in there and they didn't delete them. But you're not supposed to have these in a repository. Okay, so like none of those things. So the way git ignore works is you list everything you don't want to go in. Let's suppose, I have files called my notes. Okay, let's suppose I keep my notes .txt in my repository, but they're for me. They're my notes. I don't want anybody else to see them. Then I put it here in the git ignore file. So now that can never escape into the online repository. Okay, so you list everything you want to ignore. All right, that's what it is. So we do that first. Now I'm going to show you a little bit of a trick. This is one way to do it, and this is the common way. This is the typical professional way. There's another way to do it that I use very often, even though maybe I'm not supposed to, but I like it, so I do it anyways. So one way to do this is you list everything to ignore. It's probably the proper way. There's another way to do it. It's to reverse that logic. You could say ignore everything. That's the star. So that store says ignore everything. Okay, ignore everything. And then you reverse it by saying, except, the exclamation point means not. Okay, except don't ignore Python files. Don't ignore README files. Okay, so this kind of get ignore file is the reverse concept. It starts by ignoring everything, and then it makes exceptions for what you want to get into the repository. So there's pros and cons of each. This style right here is very good for small projects. It's very good for very high security projects, especially if they're small. Because what it does is it starts from a conservative position that says ignore everything. And then it forces you to list only what you want to get shared. Right. So for me, I like this way of doing it because it's very explicit. It forces me to explicitly say, yes, I want this to go out into the world. Okay, so it's very purposeful. Okay, it's very deterministic. So I like this. I use it very often, but it's more common to do it this way. All right. Now I don't like this way as much because like if you forget to put something in here, like let's suppose you have a file called passwords, okay, and you meant to put it in the get ignore, but you forgot to put it in the get ignore. And then some other time you execute a command that says, hey, all of the current changes, like throw them up into uh, um, on a GitHub, right? That file can escape. Okay, so that's why I don't prefer this method, even though it's the more common, it's the more professional method. Um, and now, so I said there's pros and cons of both. The way I like to do it, where I get ignore everything first, it feels more secure to me, and it's better for small projects. But it gets out of hand on big projects. So the other way of doing it, to ignore everything first, when you start getting a project very big, like you have to go find every single file that you want to keep track of, and you have to start listing it. And then you have to start in, because you don't want to list every file by name, you start listing wildcards. And when you start putting wildcards in there, it starts getting big and messy. And then sooner or later you put a wildcard in you didn't mean to, and you're right back to where you started by having an insecure system. Okay, so the ignore everything method can get out of hand on very big projects. Whereas this method, it's a little complex for small projects. Right? That's the bad part. But then in a big project, it tends to stabilize at a certain level, and then you don't really kind of add more to it. Like once you've kind of figured out most of the things you need to ignore, you can then start adding lots and lots of other stuff that you don't want to ignore, and it works out well. Okay, so two different methods for purposes of coursework. I don't care which one you use, so long as it's correct. Whichever method however you approach it, I don't care. I just care that you use a method that is correct and that makes your code secure and that keeps bad things from escaping. Okay, so we're gonna leave this as it is. Okay, we're gonna save it. Okay, so now if we look out here, we list the code again. So you notice up here the get ignore was 0. Now the get ignore is 132 bytes. Okay, so it's obviously got stuff in it now. Okay, so that's my get ignore. I'm gonna leave that aside now. Let's go on to the next slide. All right. So we keep talking about get ignore and what we should commit and not commit. Never commit secrets. That's insanely important. If you're a web developer, a perfect example is your htaccess file. So in a web development environment, you're going to have an htaccess file that's going to control a lot of the security on your site. And if you let that escape out into the world, well, then everybody knows your secrets. Okay, so we don't ever commit passwords, API keys, database credentials, private keys, tokens, environmental files, secrets in them. Production configuration. You don't commit corporate secrets. You don't commit corporate documentation that you don't want the rest of the world to see. Even if your repository is private, it doesn't matter. Okay, I have seen this happen so many times, it's ridiculous. Even in big companies. For example, I worked for Apple. I worked in a department called Worldwide Business Intelligence. Like I was head of that department, and there was another department, okay, called North American Business Intelligence, and we were looking through the North American Business Intelligence repositories one day, and we came across like all their passwords. Like somebody committed all their passwords into their repositories, and this is Apple, like a company that's very concerned with security, right? Like they're hyper concerned. You want to get fired fast from Apple, just make a security mistake. So I found all their passwords in this other team, and when I said like, hey, you guys got all this stuff like out in the open. They said it doesn't matter because the repository is private. No one else can see it. And I said, well, I saw it. And they said, oh, well, everybody else on this network can see it, but nobody else outside this network can see it. And I look around, and who else is on this network? Well, there were a lot of people. Okay, there were just customer service agents. So like that's not security, right? So we got to be careful about what you commit. So you don't ever commit stuff like this, all right? And yes, that turned out to be a big hassle that we found that. But it happens. My story is not that is that, particularly about Apple, because that's not the story. The story is it happens even in big companies, it happens in small companies. You got to be careful. All right. Assume exposure. If a secret is committed and pushed, you treat it immediately as compromised. Rotate the secret. Don't just delete the file. Don't just change. And remember, and code repositories, I'll bring us up now. It's a good place to talk about it. Code repositories are forever. Okay, forever. So it doesn't do you any good to, I'll show you. It doesn't do you any good to change. Let me go to this one, okay? Like let's suppose in this README file, I committed a secret. Like let's suppose I put a password in here by accident, okay? And then what I do is I come into that file and I erase the secret and then commit it. Okay, I delete the password and then I recommit it. Well, anyone who looks at the README file on the surface won't see it anymore. But all that person has to do is click on history. If they click on history, now you'll see all the versions. And then if this is the one with the password in it, I can just look at that one instead. Okay, and you can see it. I can come in here and go like, oh, there it is. Like I can go see it in the history. Okay, so once you put something in the code repository, it's forever. Even deleting the file from the code repository doesn't work. It's still in there because when you delete a file, what you really do is you delete the file, then you commit the deletion. All someone has to do is go back and find that deleted commit and then look at the commit right before that, and they have the file back. Okay, that's the purpose of code repositories. They keep things forever. So once a secret escapes, okay, you have no choice but to rotate that secret. I mean, change the password, change the API key, change it, okay, because it's out there, it's gone. Okay, just assume it's compromised. All right, let's move on. All right. Oh, actually, I have one more thing to say about these things. So I use the word security a lot, and I probably shouldn't have. Okay, so I may have kind of overstepped the bounds there on that term. Gitignore is not security. It is not. It is one of the steps to help secure your repository and to help secure it, but it is not itself security. Just because it's in a Gitignore doesn't mean it can't escape. It means it's more difficult to escape. And something could have escaped before you updated Gitignore. Something could have escaped because somebody forced something. Something could have escaped because you misconfigured your Gitignore. Okay, so like it's not actually security. It's just one of the things we do that goes to the total concept of security. Okay, but by itself, it's not security. All right, it's just one step on that path. All right, so now let's add a code file. So let's make a simple code file. I'm gonna do it from out here. I'm gonna say touch. I'm gonna make a Python file .main.py, right? And I'm gonna look at it. There it is. Okay. Now I'm gonna just for something different, I'm gonna edit it right here. Okay. So I'm gonna edit it right in my terminal window. Okay. I'm using VI. If you didn't see it because I went too fast, I typed VI space main.py. That'll work on Linux for sure. It might work on Mac. It will not work on Windows unless you have that installed, which you probably don't. But you can use any editor. It doesn't matter. Okay, so I'm going to now say print. Let's do hello world because we always do it. All right, so I've done that. I'm going to save the file and exit. Okay, so let's take a look. Is it different? Yeah, so main.py was 0 bytes here, and now it's 22 bytes, so I can be fairly sure it's in there. I can also look at it right here. I can say cat main.py. It gives me a listing of the file, right? And yeah, it says print hello world. Okay, so I didn't run it there. That was just showing me what's inside the file, okay? So now I've created that. Okay, I've done that. And you could have done it out here. I could just as easily have been out here. I could have like worked with it out here too, okay? And I can do both, and it doesn't matter. You can work in both. You can switch back and forth. It makes no difference. All right, let's move on. So now let's see what Git has to say about all this stuff. Okay, so we're going to use git status, and let's see what Git is doing at this point. Okay, so git status. So it tells me I'm on branch main. That's good. That tells us our configuration worked well. I don't have any commits yet. Of course, I don't. I haven't done any. I have untracked files. So Git is aware that there are new things here and it's not tracking them. We have a git ignore and we have main. Okay. Nothing added to commit, but untracked files are present. Okay. So at this point, right, I've done a status and it tells me what Git sees. I can do a Git diff that shows me what are the changes not yet staged, and I can show stage changes. Okay, so let's just look at that for a minute. Now, that showed nothing. Okay, it didn't show anything because diff shows you the differences between things that have happened that it's tracking. It's not tracking anything yet, so of course you don't see anything. And same thing should happen with staged. Yeah, nothing because I haven't done anything. Okay, we'll do this again later after we've started tracking some stuff. Okay, so we're working in this step right here. This is the inspect step. I want to see what's going on. Okay, and the next step after that is stage. Okay, the first slide, like we had those steps. I'm at the inspect stage. So if you notice what we're doing, right? What I'm doing is I made a small change. That's a small self-contained change. What have I done? I have created a git ignore. I've created a main.py. Probably those should be two separate commits. So we're going to do them as two separate ones because they don't have anything to do with each other. So both of them are untracked right now. And this is a point, right? For a beginner, you're done. Like you've done your hello world, right? That's it. I'm going to do an atomic commit, meaning the smallest self-contained, well-tested thing that I can make. But I haven't actually tested this yet, so let's do that, right? I'm going to actually run the file. Let's see if it works as intended. Okay, it does. I wanted to print hello world. It printed hello world. Now I'm tested. Okay, so if we go back all the way to the beginning to the steps, right? Edit. You saw me edit files. I just tested my files. Okay, and now I'm going to testing. A part of testing is inspecting, and then I'm going to stage my files. Let's go back to where we were. Okay, so we're here. What's next? Well, I want to stage and commit. Okay, so the first thing I need to do is actually this part. I'm still here. Actually, I was here. I'm now here. Okay, so I've done my git status. I wanna add these things. This adds them together. I'm gonna add them separately just to do something different. Okay, so I'm gonna say git add because I want to show you the difference between them. Dot git ignore. All right, now I'm gonna check my git status again. All right, now look what it says. It says changes to be committed, git ignore, untracked files still main. So I'm going to do them separate, even though the presentation does them together. I'm going to do them separate because they really don't have anything to do with each other. Creating a git ignore doesn't have anything to do with creating this program here. So I'm going to do them separate just to show you the separation, okay? So what's the next step? The next step is I'm going to do a commit, all right? So I'm going to say initial commit. I'm going to do this message here with initial commit and then some kind of message, right? But I'm going to do them separate. Like this is showing them together. I'm going to do them separate. Okay. So I'm going to do now a git commit. M is for message -m, and now I'm going to say initial commit on a basic starter git ignore. Okay. So I do that. That's okay. All right. So it says one file changed. Okay, good. All right. So what else can I do here? I can do git status again. All right, now it's telling me, well, no, the git ignore is gone, right? Because it's fine. Like there's nothing wrong with it. It's fully committed. It's added. It's committed. It's not part of this git status anymore. But it does tell me still about untracked files. So I'm going to fix that now too. So I'm going to go git add main, and I'm going to do commit it. Git commit with a message, initial commit on simple hello world. Okay, so now they're both in there. All right. So I can now do this part. I can check what's going on. Like, what did I just do? I want to see a log of what I have been doing. Okay, so check the log, and it says, well, this is what you've done. This is you made an initial commit on a simple hello world. You made an initial commit on a basic starter git ignore. Okay, so there are my commits right now. And if I check git status again, All right, it says on branch main, nothing to commit, working tree clean. That means that like everything is saved in the repository, everything is up to date. It's not online yet. Let's not confuse that. It's not online. This has nothing to do with GitHub. This is strictly on my computer. I can do a git diff again. If you're wondering what I'm doing, if you press the up arrow on the, if you don't know this, if you press the up or down arrow, you can cycle through your history. So I can check, let me check the git diff. Nothing. Why? Because there's no difference in anything. I only committed once. To see a diff, I'd have to see the difference between two different changes that were tracked. I didn't do anything yet. Same thing with staged, right? It's not going to show me anything because there's no changes that are staged. Because all I had was one change, and then there's no difference between that and the next thing because I haven't done the next thing yet. All right, so we're past that. All right, so let's talk about committing a little bit better. Good commits are small, often, and smart. This is extremely important. If you're in my courses, this is not just important, this is going to be a difference between passing and failing. If you're just watching this because you want to learn about version control and you're just like following along, this is just good advice. Good commits are small, often, and smart, which means, okay, small means one coherent logical change, one feature step, one bug fix, one test, one documentation update, one logical thing, okay, that you can describe in a few lines in a message, okay? So there's a little bit of wiggle room there depending on what level you're at. You're a beginner or you're in one of my courses, you're just starting out, your programs are small, then your commits are going to be tiny. By tiny, I mean 1 to 3 lines, okay? Tiny, okay? If you're a professional working on a very large system, your commits could be 100 lines, okay? Maybe 2, 3 functions that work together, but that's about the limit, okay? You're going much further than that, they're too big, okay? So that's what small means. Often, commit after each completed and tested step. Do not wait until the entire assignment or entire feature or entire file is complete. Now, often is a qualitative word. It's relative to what you're doing. Okay, so what's often? Well, it depends. If I've just started a project, often could be every 45 seconds because I create a file, I put a comment header in it, I save it, I create another file, I put a comment header, I save it, I commit them, I create another file, I stub 2 functions, I save it, I commit them. Okay, so at the beginning of a project, I could be moving like very fast, on the order of seconds between commits. Okay, because I'm doing very mechanical things that I want to get quickly out the door and have a history of them. All right, now think of the other end of the spectrum. There's a bug and you're working on a code base that's 10 million lines long, and there's a bug, and you're tracking it down. It takes you 8 hours to track it down. It takes you 2 hours to fix it. It takes you an hour to test it. Okay, you're going to be 10, 12, 14 hours into this, and you might have only changed 3 lines of code because it took you all that time to find it, fix it, and test it. So in a case like that, that's still often because relative to the amount of work you did in code, it's still small. Okay, so that's still often, even though it was like maybe one commit over 2 days because it took you that long to find the thing to fix. Okay, so often is a relative term. Relative to what you're doing, you should be committing often. Okay, and what does smart mean? Smart means descriptive messages. Okay, don't ever write commits like done, fixed, stuff, turning in, finished, whatever, like that. We don't write commits like that, okay? You have to describe what you did. Okay, now if you're just listening to me and you're not in my courses, that's just good advice. Everybody doesn't like the guy who just writes done, okay, or updated CSS. That's not what you're supposed to do. That's not professional, okay? So don't do that. But if you're in my courses, this is graded. Okay, so this is part of your grade. I'm going to look at your commit messages. I'm going to read them, and if they read like a story that I can understand and I can compare to your code and say, oh yes, I see exactly where that came from. I see exactly what that was. Then you get a good grade. But if I see commits like update, bug fix, final, done, turning in, finished, okay, you're getting something bad. Okay, like part of your grade is going to be very bad. All right, if not all of your grade. You have to commit with intelligent messages that say what you did. Explicitly say what you worked on, where you made a change, why you made that change, okay, if it's not obvious, okay? So small, smart, often, right? Now, read the history you're creating. Okay, so you should be able to read through your history, and it should tell a story of what you did. Okay, and how it worked. Also, you should notice that each commit has an identifier called a hash. So this thing right up here is an identifier. And we use those professionally. Like we say, like, hey, go back to this commit. This thing happened. I think that was wrong. Inspect what the person did at that point. Like, or reference this commit for this reason, or we're going to freeze the builds at that hash. Like, so go back to that point. Something like that. So these things are identifiers that define points in time in the development process, right? So read your messages, recognize these hash labels, because in my courses you're going to need them because I'm going to ask you about them. But in general, the idea is, the advice is, the message should let a reader understand the purpose of the commit, and the history is not just what you did, it's evidence of process, not storage. That's the trick here, right? That's the idea. We want evidence of the process, the thinking process, the development process. We're not just storing something and we just need a label on it. That's not what this is for. This is for um, defining and giving evidence of your process. In the real world, that matters because it's professional, and we need that history to understand what's going on, especially if we're doing like, we're debugging something, we're doing postmortems, we're figuring out why a system blew up. We need that evidence, okay? But in my courses, it's important because your evidence will be graded, okay? So I'm going to look up your commits, and if they're not good, if they don't tell me a good story, then part of your grade is going to be a 0, okay? So that's important. All right. We can use diffs to review changes. We haven't seen one yet. Maybe we'll get there if I remember as we go. Just be aware of it. Like, so if you made some changes, there's going to be some differences in your files, and you can see them. Let's see. This is kind of running long, so I'm going to kind of skip over this, right? So just be aware. Let's just try this one. Well, this compares to a last commit. So if I do something really fast, I'm trying not to take too long for this. Okay, we'll say goodbye. All right, so let's save that, and let's come out here and let's do the git diff. There it is. Okay, so there's a diff, right? That now, because I had a first commit and I've made a change, it shows me what's the difference. What's the difference between the file that I had a last commit on and where it is now? Okay, if I do git staged, okay, there's nothing because there's nothing staged. But if I stage that file and now do git staged, now it tells me the difference. Okay, so you can pinpoint where the differences are for files pre-stage, post-stage, and you can also diff commits. You can say, give me the difference between this commit and that commit. You can do a lot of things. Like, it's quite sophisticated. Anything you can think of, it's there somewhere. All right. Let me see what this one's going to do. So this one just shows, it's showing you the same things. I didn't do anything else, but this one will show me the difference versus the last commit versus the previous commit. So at this point, it's the same because it's all the same. There's only one commit, so there's no difference there. All right. I'm not going to do these. I'm just going to describe them both for time and because I don't have a way to do them right now without going forward and backwards. So you can recover things. Another reason for version control is to go backwards. Okay, because this happens to everybody. It happens, and this is a good reason why you might want to do this. You definitely want to do this, not might. You want to do this even if you're not working with other people. If you're working alone, as you learn to program, I guarantee this is going to happen to you. You're gonna write some code, it's gonna work, great. You're gonna write some more code, it's gonna work, great. You're gonna write some more code, and it's not gonna work, and it's gonna create a disaster, and all your files seem to not work anymore, and you can't figure out what the problem is, and you're looking for the bug, and you can't find the bug, and then you try to fix it, and it makes it even worse. And you try to fix it again, it makes it even worse. Basically, you're digging your own grave here, right? That happens to everybody, especially in complex code. So you make all these changes, and it just keeps getting worse and worse, and you can't figure out what to do. At some point, what you do is you do a rollback. You go, okay, I give up. I'm not even going to try and find this bug anymore. I'm going to go back to the last place I know that was good, which is going to be your last commit, presumably, okay, if you're doing things properly. And then I'm going to start over from there. So sometimes you want to go back in time and restart, right? So the restore command allows you to do that. So this restore command allows you to discard unstaged change in one file. We could also unstage something, but keep the edits. And then from that point we can also get rid of the edits. Okay, so we have backwards mechanisms as well. I'm just not going to go over them because we're running out of time, and um, I don't want to go through changing things that way. All right, so let's talk about branches a little bit. We don't want to talk a lot about them. I'm going to show you how to read them. If I do a git branch v, it tells me where I am. I'm on main, okay? And it also tells me what the last commit is, okay? So this is the important part. I'm on branch main, okay? And if you look at repositories online, now we don't have this one online yet, but I'm just gonna show you a different repository online, and you can see that it's got a branch thing right here, okay? And now this only has one branch also. I can say view all branches, but there's only one here. It says main, and it's the default branch. So, but why would we have more than one? Like, what's the purpose of that? So I'm not going to get into it. I'm just going to tell you the concept so you're aware of it. Branching allows you to work kind of like in a sideline, so you're not affecting the main line, and then you can bring your changes back in. So imagine like we're here with this green circle is, right? That's the code right now. It consists of 4 files. And now you want to add a feature. We don't want you coding on this line because you're going to screw up the main branch. Okay, so we don't want you coding here. What you do is you create a new branch. Let's say you're going to work on something called feature 1. You create a new branch. What it does is it takes all this code from here, it moves it here, and allows you to work here, kind of like in a copied area, right? So you're working over here, and nothing you do here is going to affect this up here. Like, let's suppose you're working on a feature 1 and you blow something up. Well, it doesn't matter because you've only blown up your feature 1 branch. You didn't blow up the main branch. Okay, so like that's still fine. Okay, so you work out here, and then after you're sure and it's tested and it's good, okay, you can merge it back in. Okay, you can say, yes, I'm sure this is okay. I want this to go back to the main branch. And you can further imagine, let's say you're working in a team environment. Let's suppose like somebody else is working there too. Like they can take that same main branch after you or before you or whatever, right? And they can start working on a different feature. So if you look at this point in time right here, where my mouse is moving up and down, there are 2 different people working on 2 different features off the main branch, okay, like out here. And nothing they do is going to affect the main branch or each other. So it keeps everything safe and isolated, okay? Now, at some point, like maybe this person working on a feature 2, like, this is a good picture. I like this picture because it could be like this. Maybe this feature 2 person was waiting for you to finish the first half of feature 1 because they need to do something with it. Okay, so maybe there's like some kind of coordination going on here, right? And they start working after that, but you're still working on stuff. Like, I don't know, like it can get complicated. This picture doesn't really represent all of that, but like just conceptualize it, right? Just think about like how you can collaborate across branches, like you can merge, you can pull back, you can do all sorts of things. So eventually your feature 1 is done, you merge it in, okay, and now it's back in the main line, and it's part of the code, the main code base, and eventually the other person's out with their feature 2, and then that's back on the code base. And it doesn't even have to be different people, right? Like I worked in cases where like I've created a branch for something I want to work on, but then I come up like in the middle of doing that, I come up with like some idea I want to experiment with, so I create another branch that I experiment with that maybe I know is going to be a throwaway branch, right? Now I'm working in 3 branches. I got main, I got my main feature branch, maybe I got an experimental branch that maybe I never merge back in or something like that. So it allows me to work in different locations without screwing up my main. Okay, that's the concept of branches. If you're if you're in my courses, we're not going to touch branches. I want you to know what they are. I want you to know the concept so that you can speak intelligently about this stuff. But I never introduce branching into courses because it's too much. Like we have enough trouble, and we need to work on more important things. When it's time for you to work on branches, you need to be fairly sophisticated with the rest of the concepts, and then go into branches. Like don't go into branches as a beginner. It's not worth it. Okay. All right. So I think I basically covered this slide already. Yeah, concept only for now. So this slide's kind of important for my students. If you're in my courses, you will have another branch. You won't have to work with it though. Okay, so that part's still true. But you're going to have another branch that I use to give you feedback. So if you're in one of my courses, you'll have a repository like this, and you'll pull this down, and you'll see another branch here called feedback. okay? And you'll also see a pull request up here, right? And those are places where I manage them. You never have to touch them. You never have to do anything with them other than read them occasionally if you want to. So you can go into those other things that I manage for you, and you can look at feedback. You can look at automated testing results. You can look at comments. You can put comments in there, but you never have to work with them. Okay, so you don't have to worry about them in my courses, and you don't have to. Click the wrong button here. Hold on. I want that. Okay. And if you're a beginner, ignore all that. Like, just understand the concept and move on. Okay, so local Git is already useful. You can track changes over time. You can inspect diffs in history. You can recover previous states. You can maintain discipline development checkpoints. Okay, so this is really important. Like I said, even if you're working only locally, it still provides a lot of value. And then when you start working with integrated development environments, it provides even more value. Like, I really don't know what I would do without using Git all the time, even on local projects. Like, it's invaluable. Okay, it just makes you so much better at developing and keeping track of your stuff. So that's all local. We haven't done anything remote yet. Okay, so what does a remote repository add? Okay, so this is a good place where I'm gonna pause the video to take a break. This is a good place where you can pause it, maybe take a break and come back to it 10 minutes or tomorrow or whatever you want. So it's a good logical break because we finished our local repository. Like, it's done. Like, we have it. Like, even though our status says we have a modified main, but it's being tracked, and I could commit it or whatever. Actually, I'll do it now just to make sure it's clean. All right, and if I do a git status, nothing to commit. We're going to be clean. But now I can't push it anywhere. I'm not online. Okay, this is just me working on my own stuff. Okay, so we'll stop there. We're going to pause this, and then you come back when you are ready to come back.